This meeting is being recorded.
In this video from chapter 17, we're now going to take a look at how we can find the molar solubility of silver bromide in a 3 molar solution of ammonia. So what we see down below for sample exercise 17 is our two equations here combined. So remember, this is a combination of both the salt ionization and then the complex ion forming equation as well. So we see this Kc value given over here, respective of the combination of these equations. So this Kc is for both the Ksp and the Kf. So we've already found that at this point, where we had to solve for that in previous problems. So let's see where we got these values that we plugged into this KSP expression. So we'll not include any values from our solid. So we'll start our ice table over here. And we see that initially we have 3.0 molar and 0 and 0 for our two products. So our change, this is going to be plus X or plus S, right, for solubility. Over here, plus S and plus S. So these are our two products that we're plugging into our equation. And then our change here is going to be minus 2 times our S here. So we're going to have at equilibrium 3.0 minus 2S. All right, so that's what we've plugged in down here. And we have to remember, because of this coefficient, that 2 in front of the ammonia, that we square our denominator here. So let's plug in some values. So we're going to set our Kc to our, oh, that's 2.8, that's 8.0. So let's start over here. So we have 8.0 times 10 to the negative 6. That's our Kc. And that's equal to S squared over, we're going to not consider that small change there in our equilibrium of our ammonia. So we're going to have just S squared over 3.0 squared. So let's rearrange this. Oh, that's gone. So now we're going to multiply, or actually first we're going to take the square root of both sides. So we'll simplify our equation. So then we get this value over here, 2.83 times 10 to the negative 3. We'll multiply that by the square root of 3 squared, so times 3.0, and this will be equal to S. So our solubility for this is found to be about 8.5 times 10 to the negative 5th molar. And again, that's the molar solubility of our silver bromide. There's one other thing that I wanted to talk about in this video, this concept of amphoterism. And when we have these compounds that are referred to as amphoteric, those can act as acids or bases. So the solubility of these can be increased by putting in acidic or basic solution. So what we see here is, say we have a metal hydroxide, aluminum hydroxide, one of our examples of these such cations. If we add this to an acidic solution, our equilibrium will shift this way because we're seeing this reaction here. Our aluminum hydroxide reacts with the acid, and we neutralize it, we get water. So this would increase solubility acting with an acid, and the aluminum hydroxide acts as a base. And then it can also react with hydroxide, and we'll shift this way. We'll see this equation up here, and the formation of a complex ion when aluminum hydroxide reacts with a base. So again, we can increase the solubility by adding acid or base. So add acid or base will increase the solubility of an amphoteric compound.